Almost 2 years ago, one of my friends purchased a portable monitor to use for his PC setup. It was a pretty nice monitor for its price, but it had one flaw. The monitor stand wasn't the best. Within 48 hours of having the screen, I was over it and I began brainstorming ideas for a new stand design. I wanted a base clamp design that would support the load of other components as well as the Lepow screen while remaining structurally sound. The results of the first base clamp design were not what I was expecting, and I had no faith in the design's ability to stand the test of time. I took some time out to do some brainstorming to come up with solutions to the issues discovered in the first base clamp design. Several weeks later, I was back to the drawing board with a fresh mind and newer ideas. To start the new base clamp design, I stripped the original base clamp of almost all its design features and deleted some original components. I deleted the original handle, the original adjustable screw, and the original movable jaw, leaving the original fixed jaw and lower frame as my starting point. After stripping the design down to the fixed jaw and lower frame, I saved the file as version 2 of the design to preserve the original version and give me a fresh start for the second version. Once that was done, I began executing the second base clamp design. First, I adjusted the overall size of the clamp design. Another issue with the components of the original design was that they were too long, which wasn't ideal for the structurally sound foundation I was looking to achieve. I made structural improvements to the inner angle of the fixed jaw. This time around, I utilized more of the free space that served no real purpose in the original design. Remember the third screw that I added to the lower frame at the last minute of the original design? Well, I took that screw and placed it above the surface of the lower frame to keep the lower frame attached to the fixed jaw to prevent the separation seen in the original design. I added a 1/2 inch thick rib in the inner angle of the lower frame to make the lower frame stronger, and I added the screw holes again, but this time on both sides of the 1/2 inch thick rib. I cut some material from the inner angle of the fixed jaw, so the component uses less material during printing, and it looks cooler without jeopardizing the structural integrity. After finishing the fixed jaw and lower frame, I began designing the second version movable jaw and adjustable screw. For the second version of these components, I completely changed how they mate. Instead of a single screw connection I had before, I replaced that with a ball joint connection. I switched back to the ACME threads for the second design version of the adjustable screw. Following my research, I thought using those threads would be more beneficial to the design. This change not only eliminated the need of an additional screw and nut, but it also gave the movable jaw more degrees of freedom, which would ensure that the surface of the movable jaw remained parallel with the bottom of the desk, even if the clamp shifts during tightening. I also discovered that the Gorilla Grit self-adhesive bumper pads made more sense in the second version of the movable jaw design than in the original version, and here's why. In the original design, I used a screw and internal nut to mate the movable jaw to the adjustable screw, making the components fixed together. To tighten the clamp, you must turn the handle, which in turn turns the adjustable screw, which in turn turns the movable jaw. Since I'm using the self-adhesive bumper pads in my design to create friction between the smooth surface of my 3D printed components and the surface of my work desk, having the bumper pads would only make turning the handle unnecessarily challenging in the original design because of the friction created between the bumper pads and the surface of the desk. And given that the movable jaw is fixed to the adjustable screw with no degrees of freedom, the extra friction can cause wear and tear to these components over time, which isn't ideal for the overall longevity of the design. As I've said in the past, you live and you learn. Anyway, moving forward, I began designing the second version handle. The original handle was nice, but I wanted a handle that was wider and felt more comfortable in my hand. I also wanted the handle to be bigger to give more leverage when tightening the clamp. During my brainstorming, I thought of ways to ensure that once the clamp was fully tightened, it wouldn't loosen over time. To prevent such an issue from arising, I created a special lock pin that is inserted between the lower frame and the handle. The purpose of the lock pin was to hold the handle in place once fully tightened so that it won't loosen over time due to forces like vibration or general wear and tear. This feature may have been overkill for my application, but it can prove useful in others. Plus, it promoted the longevity and structural integrity of the design, so I figured why not. After all the design changes were made, I added the .03 fillets to the completed components once again, and I put my name on the outer surface of the fixed jaw, this time with more added wording. Making last minute adjustments again, I removed one of the 1/2 inch diameter indents from the bottom face of the fixed jaw because it was no longer necessary for the second version of the clamp. It was now time to print out the components for the second version of the base clamp design. Each component was printed at 70% density for strength with an overall print time of 143 hours. I assembled the components one at a time as they finished printing, and everything was smooth sailing until catastrophe struck once more. The ACME threads weren't functioning the way they were designed to. There was entirely too much friction when attempting to turn the adjustable screw. Even for the isometric threading, there was some challenge getting the threads to function properly the first time around. However, the threads would begin to function smoother after a while of turning back and forth. But in the case of the ACME threads, I couldn't get the adjustable screw to turn at all, and it got to the point where it started to hurt my hands. The further I turned, the harder it got, and eventually, despite the density of the print, the adjustable screw snapped right off the bottom of the lower frame, leaving the remainder of the adjustable screw stuck in place. This happened not just once, but twice, even after changing the diameter of the adjustable screw, thinking that would prevent it from snapping again. Although the ACME threading is more commonly used for clamping over the isometric threading, I noticed a slight difference in print quality of both threads. The ACME threading had a rougher finish than that of the isometric threading, which led me to believe that that was the source of my issue. But even after switching to the isometric threading, the adjustable screw snapped again for the third time. I was left puzzled and frustrated about what was happening, and I could not understand why, because the threading for the original version of the design functioned even better now after tightening and untightening so many times. 3D printers are very precise, but depending on the type of printer you use, your prints can be off plus or minus 1 to 5 millimeters. Now, to the naked eye, that's practically nothing. But when mating prints together, especially dealing with threading, you can feel the difference. I know I did. I sat in my frustration for a while, but then one word came to mind: lubrication. I knew that the isometric threading worked because it worked in the original version, but maybe if I added a lubricant of some sort, it would solve the new issue I was facing. I printed out the new adjustable screw, and I was able to salvage the lower frame by removing the snapped adjustable screw with 2 heavy screws and a set of pliers. Fun fact, I use the same method to open a bottle of wine when I don't have a corkscrew. Grab 2 screws, a screwdriver, and a set of pliers. Screw the screws into the cork on opposite sides, one on the right and one on the left. Be sure to screw the screws in at an angle towards the inside of the cork to get the best grip. Grab both screws with the pliers, turn slowly and pull simultaneously. If your cork begins to crack, don't be afraid to reposition your screws. Gently turn and pull until the cork is removed. And there you go, a little life hack for you by TinkerPro. Warning, the use of this life hack is prohibited to viewers under the legal age of alcohol consumption and should not be attempted under any circumstance. After the 4th adjustable screw was finished printing, I grabbed some Vaseline, or petroleum jelly to be technical, and I applied it to the adjustable screw threading and the threading of the lower frame. I carefully turned the adjustable screw into the lower frame, and it was still tough, but sure enough it worked, and the project was back on track. The clamp was designed to clamp down at the thickness of my work desk, which was only 3/4 of an inch. So I added a piece of cardboard to add additional thickness, thus making the clamp tighter to the desk. One piece of cardboard worked just fine, but I wanted to test the limits of the clamp, so I added another piece of cardboard to see if I could create an even tighter grip. Doing so, I pushed the clamp to its limits. and again catastrophe struck. The clamp began to crack and eventually snapped between the fixed jaw and lower frame. But that was okay, because I wanted to know exactly how far I could push the clamp before it failed, so I can take that data and make changes to the design to make it even stronger. Or at least that's what I told myself at the time to make me feel better. I was really sad when it broke. Jumping back into my design, I decided I wanted to change the handle again to something even wider and smoother. I deleted the second version handle features and designed a third version that was much simpler and easier on my hand. After finishing the third version handle, I started adjusting the second version clamp to address the weak areas of its design. I beefed up the inner angle areas of the fixed jaw where they separated during testing, and I made the outer wall of the fixed jaw a 1/4 inch thicker than it was before. For the lower frame, I did the same thing, beefing up the areas where failure occurred and making some slight aesthetic changes to the design as well. Lastly, I made some last-minute design changes to the movable jaw, making it wider like it was in the first version, however cutting off some material to adapt to the newer design parameters. Once those changes were made, I printed out the new components for the last and final clamp design. The final design was a success. The clamp worked perfectly and it was securely clamped to my desk with no signs of failure. It was now time to continue with the rest of my design.